Hi there, this video is going to cover Chapter 4, Section 3, Hyperbolas, the equations of the hyperbolas, and it's actually day 2 of that. So we're on 4.3F, day 2. So on yesterday's video, we worked through some of the examples, and we're going to pick up where we left off. And that's with example 9. So example 9 says find the equation of the hyperbola. So we're ending in the same spot. We want it to be the standard form of the hyperbola. We start with x-intercepts this time. So if you graph an x-intercept, this means it's going to cross through the x-axis at this point. So negative 3, 0, and positive 3, 0. For a graph to intersect there, we're not sure yet that those are vertices because it could just cross through at that point. But the second piece of information that it gives you, which is that the foci is negative 5 and positive 5, tells you that this is now a horizontal hyperbola. If it intersects there, then those are my vertices, which means my center is halfway between them. Center is 0, 0. And that the A is 3 and the C is 5. So I know it's horizontal, x squared minus y squared equals 1. I know the A squared would come first, so 3 squared would be 9. And I need to know B squared. Since C squared equals A squared plus B squared, 5 squared would equal 3 squared plus b squared. 25 would equal 9 plus b squared, and b squared would equal 16. That makes b 4, but we don't really need to know what b is. We just want that b squared, which is 16. So x squared over 9 minus y squared over 16 equals 1. All right, number 10 says find the equation again of the hyperbola. This time the y-intercepts are at 0, plus and minus 9. So we're going up, 9, down, 9. And the foci are at 0, positive 15, and 0, negative 15. So I actually know, I'm not going to go all the way up, but I know that the foci would be here and the foci would be here. And that tells me it's vertical. And it tells me that those y-intercepts are my vertices. So my A is 9 and my C is 15. And the center would be halfway between them, which is at 0, 0. So it's vertical, which means y squared minus x squared equals 1. The A would be my 9 and 9 squared is 81, and B is what's missing. So same as the last one, c squared would equal a squared plus b squared. 15 squared would equal 9 squared plus b squared. 225 would equal 81 plus b squared. Subtract the 81. And b squared is 144. So my equation is y squared over 81 minus x squared over 144 equals 1. All right, example 11. Vertices at plus and minus 10, 0. Keep doing that, sorry. So positive and negative 10, positive 10, those are your vertices. Already I know that this is horizontal. Halfway between these would be my vertice, or would be my center, which is 0, 0. And A is 10. So x squared minus y squared equals 1. And x squared is over 10 squared, which is 100. Now go to the second piece of information that they give you, which is the asymptote. because it's horizontal, y would equal b over a, or plus and minus b over a, x, which means b over a equals 5, which would be over 1. Since a is 10, b over 10 would equal 5, or 5 over 1. And if we cross multiply, b is 50. B squared would be 2,500. So our standard form of our equation is x squared over 100 minus y squared over 2,500 equals 1. All right, this one, vertex or vertices at 0, -5, so down 5 and up 5. Those are your vertices. That means this is vertical. Center's halfway between them. Center's at 0, 0 again. A is the distance from the center to that vertex, which is 5. So it's y squared minus x squared equals 1. The y goes over the a squared, which is 25. So I'm just missing b squared. And it gives me passes through this time. So this is my x and this is my y. 10 squared over 25 minus 3 squared over b squared equals 1. 10 squared would be 100 over 25 minus 9 over b squared equals 1. And we want to isolate that b squared. So we're going to subtract the 100 over 25, which actually simplifies to be 4. And I get -9 over b squared equals -3. 3 over 1, we can cross multiply here, -3. B squared would equal -9. Divide both sides by -3, and b squared is 3. So I go back to my original equation where I was missing the b squared, and I plug in the 3. All right, 13 says the foci are at plus and minus 3√5. This tells me my center is halfway between them. So center at 0, 0, horizontal. So x squared minus y squared equals 1. And I have that y equals plus and minus 2x. So because it's horizontal, my b over a is going to equal -2. I don't know for sure that b is -2 and a is 1 until I test it out with my c squared equals a squared plus b squared, because it could be simplified. So c squared would be -3√5, or actually positive 3√5, because it doesn't matter. 3√5 squared equals 2 squared plus 1 squared. 3 squared would be 9. Square root of 5 squared would be 5. And this is 45 equals 4 plus 1. And that's obviously not accurate. So the tricky part is here, trying to figure out what two perfect squares add together to give you 45, and then their ratio would be 2 to 1. So if you think about your perfect squares that are obviously both perfect squares and the ratio of 2 to 1, and that would be 9 and 36. When square rooted, it's 3 and 6, which is 2 to 1. So I know that these are not my actual values for A and B. I know B should be 6 and A should be 3. That would still simplify to B 2 to 1, but when I square them both, I get 36 plus 9, and that's 45. And that's the only combination that works. So my B is 6, my A is 3, and the x squared is going to go over 3 squared, or 9. The y squared is going to go over 6 squared, or 36, equals 1. Now, if we couldn't have figured out the A and the B by just like trying and plugging in some perfect squares, then you can actually have set up a systems of equation. So just a quick side note, you won't have to do this in your homework, but should it ever appear on a standardized test or anything like that, I can say that A squared plus B squared would equal 45, because that's what it should have equaled over here. And that A should be 2 times A should be my B. So 2A should equal B, which means I can literally plug this in to the B, and I can get A squared plus 2A squared equals 45. So using substitution here, and then combine my like terms, A squared would be 9, and A is 3, and then plug it back in. 2 times 3 equals B, and B is 6. So we got lucky by kind of just like picking ones that worked. If you couldn't figure that out, you can set up a systems of equation and solve it that way. Okay, last question, and the first where our center is not at 0, 0. So we've been kind of waiting for this one to happen. If you have 2 vertices, 5, 1, 2, 3, 4, 5, -2, and 1, -2, these are my vertices, that don't split center, then 1, this still tells me a couple of things. They're horizontal. So it's an x squared minus a y squared equals 1. But my center is no longer at 0, 0. So if you've got a graph, you can count it out halfway between 1 and 5. This one should be a little bit further over here. Sorry, this would be 1 and -2. So halfway between those, there's 4 spaces between. Halfway between would be 3, -2, which I can see from my graph. If you don't have a graph, or you would rather use the midpoint formula, I can do 5 plus 1, so 6 over 2, -2 and -2, so -4 over 2, and I get 3, -2. So either way, I get my center, either the midpoint formula or my graph. And now I know it's x minus 3 squared minus y minus a -2 becomes plus 2 squared equals 1. And I still have to go A squared and B squared. A is still the distance from the center to the vertex. So A is 2. And I know this would be 4. Now I have to move on to the second piece of information, which is that asymptote. And that asymptote is in the weird format because it has a center that's not at 0, 0. So y equals k plus and minus. It's horizontal. So B over A, x minus h should be the equation I use for an asymptote. I know the k is -2. I know the A is 2. And then x, the h is 3, so -3. Now everything matches, -2 and -2, x minus 3 and x minus 3. So it's just confirming what I found, which means I could have found my center from here too. All that's left is the 3 over 2 equals the b over a, or the b over 2, which means b is 3. And the denominator here, which should be b squared, is 9. So don't forget to submit your full notes for the hyperbolas. You can do from yesterday and today. So just the examples of the writing of the equation, or you can do your full hyperbola. It's just a big note. So I know it's going to take a while to upload. You want to make sure you submit those to today's assignment, and you're going to use the rest of the time to work on the 4.3F homework. Have a fantastic day, guys, and I will see you soon.